Take a look at any clock on your wall, your phone, or your watch. The hands always move the same way, clockwise. But here's the thing. There's no law of physics that says time has to move that way. So why do clocks move clockwise instead of the other direction? The answer isn't really about time. It's about shadows, the sun, and decisions made thousands of years ago. Most of us grow up thinking clockwise. Motion is just normal. We even define directions using it. Tightening a screw, turning a knob, opening a bottle. Clockwise feels intuitive. But that intuition only exists because clocks came first, not the other way around. To understand why clocks move clockwise, we have to go back to a time before mechanical clocks even existed. The earliest timekeeping devices weren't clocks. They were sundials. A sundial works by casting a shadow from the sun onto a marked surface. As the sun moves across the sky, the shadow moves too. And here's the key detail. In the northern hemisphere, the shadow on a sundial moves from left to right over the course of the day. That motion, caused entirely by Earth's rotation and the sun's position, is what we now call clockwise. No gears, no design choice, just astronomy. This part is important. Most early civilizations that developed advanced timekeeping lived north of the equator. Ancient Egypt, Greece, and later medieval Europe. When they built sundials, the shadows all moved in the same direction. If early clockmakers had lived mainly in the southern hemisphere, clocks might have ended up moving the opposite way, but history didn't unfold that way. So when mechanical clocks were invented in Europe around the 13th century, their gears were designed to imitate the motion of sundial shadows. Clockwise wasn't chosen because it was better. It was chosen because it was familiar. Early mechanical clocks didn't track minutes or seconds. They mostly showed hours. And accuracy wasn't the main goal. What mattered was consistency. Clockmakers built rotating hands that followed the same path people already associated with time passing. Once that standard was set, it spread quickly. Church towers, town squares, public clocks, all reinforced the same motion. And by the time smaller clocks and watches became common, clockwise movement was already deeply ingrained. At this point, you might wonder, why didn't anyone ever change it? The short answer is momentum. By the time alternative designs were possible, the world had already standardized around clockwise motion. Changing it would have meant re-educating everyone, redesigning clocks, and breaking consistency across countries. And there was no real benefit to doing that, so clockwise stuck. Not because it's better, but because it was first. Here's something most people don't realize. The terms clockwise and counterclockwise exist because of clocks, not because of nature. Without clocks, we wouldn't describe rotation that way at all. Time didn't define clocks. Clocks defined how we talk about time. So the next time you watch the hands on a clock move, remember this. They're not following a universal rule. They're following the shadow of the sun as it crossed the sky thousands of years ago. This has been Questions Answered. And if you've ever wondered why something works the way it does, you're in the right place.